Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last video we encountered a problem where we were trying to initialize the engine from the editor and couldn't export these symbols from the main process. So to recap the problem, in order to use the Agility SDK, we need to let the Windows application loader know what version of the SDK we want to use and where it can be found. We do this by exporting these two symbols, which will be picked up by the loader, and it will then load the proper DirectX DLLs for us. However, this can only work when these symbols are exported from the main executable. When we want to initialize the renderer from within the editor, this code here is no longer part of the main executable. That would be this host application that's provided to us in order to load the editor code, which in turn loads the engine DLL that contains the engine code. So if we want to export these symbols, it should be from this executable and therefore we have to replace it with our own. Now there's good news and there's another good news. So consider today a lucky day. The first good news is that we can replace this executable with our own, since Microsoft provides the means to do so. The second, even gooder news is that apparently exporting these symbols is no longer necessary thanks to a new interface in DirectX 12, which can be used for selecting the SDK version during initialization. I was made aware of this new interface by one of my viewers, Matthias, who also provided the code snippets to get it working, for which I'd like to give him a big shout out as well. This was, however, only after I already recorded this video. So most of the code that you'll see me write today is going to be removed again in the next episode, and therefore you can feel free to skip watching this video. There could be some small bug fixes at the end though, so you might want to skim through the video unless you're really interested in replacing the host application, in which case buckle up and let's jump right into it. Now, in order to replace this executable, we need to write a little C++ application that calls a few functions in order to load a .NET DLL and run its code. These functions are provided in libraries that are found in this location. So the steps for making our own host application are as follows. Create a C++ project and write the code for running a .NET application. Build this project during a post-build event of your .NET project. So after building the PrimalEditor project, we also built the host application. Finally, swap the default host application with ours. Let's create the host project. I'll create it outside of the Primal folder, since we don't need the entire solution. I'll copy the parts we need to a folder within PrimalEditor when we are done configuring the C++ project. So here we create an empty C++ project. I accidentally made more subfolders than needed, but that's okay, we'll delete this solution after we copy the needed parts. Here we add the main.cpp. We can copy the main code from the engine main function to save time. By the way, I'm not going to explain this in depth and I'll move quickly through this since we are going to do it differently later anyway. So if you have any specific questions that are not answered here, then feel free to ask them in the Discord server. You can find the link below in the video description. Here I'll select C++ 17. And we need this application to be a Windows executable, which we can configure in linker options under Stop System. Make sure that you select all configurations. Next, include the needed headers and remove unnecessary code. First thing we do is to get any command line arguments that we'd like to pass to our .NET application. Right now we don't use any, but it's nice to have the option. We put the name of our .NET DLL in the first argument. This is required by the launcher function, which we are going to write in a minute. Then we append other command line arguments, if any. Note that this function allocates memory, which we have to free at the end when we exit the main function. This will already produce an executable, so let's try and build it. As you can see, it runs, but obviously nothing happens because we don't do nothing in here. We write the run app function next. Here we are going to call functions exported by the hostfxr DLL. We locate and load hostfxr DLL in this function. The function declarations and types that we need here are found in these header files. Right now, Visual Studio doesn't know where these headers are. As we'll see in a minute, the location of these headers will be provided by MS-Build when PrimalEditor is built. After loading this DLL, we can use it to get the function pointer to a function for loading a .NET application. We also get another function pointer for running the loaded .NET application. Again, all these types are unknown because the headers here can't be found by IntelliSense. So our .NET application is loaded and initialized by calling init, which returns a context that we can pass to run in order to execute our code. Now we can build this native host application in the post-build event of the editor's project. Here we define the path to those header files that Visual Studio couldn't find. You can see that this corresponds to the path we see here in the File Explorer if we fill in these macros. Then we delete the original host application and build our own. One difference now is that we also have to copy net host DLL, whereas the original host didn't need it. I don't know why that is, and it also doesn't matter, because like I said, we are going to pull this code anyway. Now I'd like to rename this native host, which helps to ease my OCD. Well, actually we only need main.cpp and the project file. I'll copy these two to the editor host folder within the PrimalEditor folder. We can see them appear here in the Solution Explorer. We get an error while building the editor host. Before fixing that, let me free the host FXR DLL at the end. Let's delete the project file here and configure it in the original solution first. I kinda messed it up a bit with this renaming, so I'm trying to fix that here. Okay, in order to configure the project, I'm going to remove all 32-bit build configurations first. In addition, we renamed the build configurations to Debug Editor and Release Editor. These are the same names we use for building the editor as well. In the linker options, we have to provide the path to the host libraries. As we just saw, this path is provided by the build system during the post-build event. For the compiler options, we have to set additional include directories using the same macro. Again, don't forget to select all configurations before setting these options. This project has its own post-build event, where we copy the resulting executable to the output folder of PrimalEditor. This effectively replaces the original host. I'll clean this up a bit before copying it. This time it can't find the headers and libraries, but I made a typo which I need to fix. And that's it. The native host has been replaced by the new one. Okay, the project name is still messed up in the original solution, so let me fix that. The reason I want this to work is that I'd like to add an icon to our host app, and here I'm looking for the Toolbox tab in order to add an icon resource. Earlier I made an icon file with Primal Engine's icon, which we can use for this. Here we see 3 additional files, which we also have to copy to Primal's folder. Oh, and I totally forgot to do the thing that was the purpose of this whole exercise, which is exporting the symbols from the native host. We can put these right here. It seems to be working, but for some reason I don't see the icon. Let me clean this folder and rebuild it. Oh, I know why. That's because we also have to update the project file to include the new files. And here we see the icon. Although not sure why there are 2 executables here. Anyway, now when we run the editor, we see that the renderer was initialized successfully. Let me see why we have 2 of these though. Okay. The output directory of the C++ project is the same as the one used by Primal. We have to set this to project dir instead. Okay, so this is a new part which I can copy to the other project in Primal. I'm sorry if this is confusing, but I've done this only once before, and that was almost 2 years ago, so the steps are a bit blurry for me as well. Okay, this should be good now. Rebuilding the editor, we see only one executable with an icon. Setting a breakpoint now and looking at the call stack, we see that the application was started here in the C++ code. I think that was all we needed to do to fix the problem with exporting the symbols. I'll do a bit of code cleanup before wrapping up. This is not needed here. I forgot to change these to integer types as well. And here is one I remember wanting to fix. Well, officially I shouldn't be touching shader code in this video, but it's a small fix. And that's it. Next time we are going to work on adding support for the geometry component in the editor. By the way, let's also quickly check if the engine shuts down correctly, or in other words, we don't have any live objects. Which appears to be just fine. And make sure that the test application still works as well, which it does. Oh, and also see if it works in release build, of course. Okay, so this is a problem that occurs when building the release build twice. The first time it does put our host application in the output folder, but the second time it replaces it with the one that Visual Studio makes for us. As you can see, I can rebuild this and we have the executable with our icon, but as soon as I run the editor, it replaces it with the original one, which fails to initialize the engine. To fix the problem, we have to change 2 things. First, we tell Visual Studio not to use the host app. As you can see, this time it didn't replace the executable. However, it won't run it either when we try to launch the editor from within Visual Studio. It tries to use .NET.exe to launch the editor's DLL, which fails because of the same issue. To make Visual Studio use our host application, we have to go to Debug Options and make a new launch profile. So first we remove the old one, and when adding the new profile we choose Executable. And here we type the name of the executable that it will use. Also check native debugging option in order to be able to debug C++ code. Now when we press F5, it runs our host application, which loads the editor and the engine successfully. And with that, we have reached the end of this episode. As I mentioned, I'm going to undo this code in the next episode and use the proper DirectX interface functions to select the Agility SDK, which can be done just by adding a few lines of code, and after that we'll start working on geometry component. As always, thank you for joining me and I'll see you next time.